Okay, so we're gonna talk a little bit about the computing systems, its components, right? Some hardware information, a little bit of the OS. I think from the perspective of how the concept will be applied to digital forensic, that's kind of important to know. And so this can be review or refresh for many of you. So, um, you would know that there's a vast amount of different technical systems, right? We basically kind of categorize based on OSs, but you would see that in the digital forensic area, you might come across Android devices, but with different model. But ultimately, we want to think about the computing systems as something that would have a processor, something that would have a storage. And we're in forensic, basically, we are looking for data, right? Information that's going to give us more details about the case. So it's recommended that we want to have the procedure and processes that would be related to the systems, that you understand the type of processes that's happening inside the systems. So having the knowledge and the understanding of the physical systems, right? The media, the processor, the memory, we're going to have a whole chapter on that, is important. Okay. So let's start with the boot process. For most part, right, if you are looking at like a Windows PC or even a system, all systems have some form of boot process. For example, if you're looking at a Linux system or an Android system or an Apple system, it does go through a boot process. Linux system would have a boot section of the drive that it refers to. All OS does that, right? Same thing with Windows, and it would refer to the BIOS for Windows PC to kind of identify the type of hardware components that it's working with, right? And so the power on self test here just refer to that it's going to check to make sure that all the hardware components are communicating or usable, right, before the OS loads. So it's going through and it's going to check. And so in the case if you have disconnected RAM or something happened to your drive where it's not able to access the C drive to load the OS, it will give you some kind of sound. So traditionally, the old system, it would be, right? Now you would see that happening with UEFI on the newer OS. But ultimately, BIOS is something that's written on ROM, okay, for the motherboard to identify the components. And so it would be able to check all the bus or the path for the device that are connecting. So in the first question, we can answer, why does the digital forensic investigator need to know the different operating systems, file system, and boot processes, right? You know that every operating system uses different file system, and it's important because your technical knowledge about the OS, the file system, and how the system boots really help you make less mistakes or error in your investigation. And when you make error, that can change the outcome of your investigation or the artifacts that you're gonna find. So, for example, right, like you know that when you plug in a USB drive, it can sometimes do an auto run, and we don't want that to happen because it would open up the container of the storage for the USB or the micro SD. So we want to have this knowledge so that way we can predict and prevent things from happening that can impact our investigation. And you want to have integrity in your outcome, in your result, right, in your investigation. And you want to make sure that that is maintained for your credibility purposes. So it's important to, right, it's important to have the technical knowledge, at least at the basic, right? Know what type of hardware components that you're working with, the operating system you're working with, how to navigate through your image files, knowing the OS and the hardware information. And as we looked at the next section of the notes, you can say the things that occur with the power on self-test, your POST or your post, it essentially identify the components that are connected to your motherboard. So it looks at your motherboard function. So what's a motherboard, right? It's a board that all the hardware components are connected to it, like your drive, your SSD, your memory, and your processor also connect to it. And so the way that the system does a power on self-test is it sends signal through the bus channel to the components to receive response. So if you have a connected drive, right, it would know because the signal would then be verified by the SSD that you connected on the motherboard, or a hard drive, an HDD, or a GPU, right, a graphic adapter, etc. So if your devices are connected and configured, right, or enabled to be seen by the system at the power on self-test, basically power, it's gonna give it power and to be able to determine, right? So it's a quick way for the system to check which devices are connected at the hardware level. You have to know that in order to get to the software level, right, all your hardware components needs to be communicated or be seen by the system. And the OS is just a way that we interact with the system through the software level to control our hardware components. So operating system allows us to manage the hardware components along with, the things that we create on the system, like files, right, data, etc. So understanding those things are going to be important, right? Any question? Okay, so where can you find answer for 1 and 2? You will be able to see the first section and the second section on page 1. And then it talks about the newer, right, interface to the hardware instead of the BIOS. You would see that is UEFI. As some of you are studying for A+, right, Unified Extensible Firmware Interface, and all hardware has some form of firmware. It is a way for the software to communicate with the actual hardware, right? And so this allows you to use the graphical user interface instead of using the actual BIOS information that is stored on ROM. So you can access it in a different way. BIOS, you normally tap, right, a function key or a certain key for that particular system. It depends on the motherboard manufacturer. But on UEFI, right, we will be able to access that behind the OS, but you have an option to navigate to it through the OS. Okay, so let's talk about MBR real quick, because this is important when you deal with partitions. Today, when you do the lab, you're actually going to look into a drive and you're going to carve out some file. So it's really important that we talk about, like, what is a drive made of logically, right? And the way that the drive is created or sectioned into different parts can be important. So master boot record, your MBR, is used to be able to boot the device, right? And it's basically, it is a section on the drive where it would refer to be able to, before it loads the OS. So it needs to go in and look for the file system. Every operating system have a different set of file system. So in Windows, if you're using Windows 10, Windows 11, anything post 7 and on, right? You would see it uses NTFS, right? So new technology file system. This allows us to be able to access file permissions. It also gives us opportunity to be able to encrypt. So different file system is going to give you different feature in how you're using the files inside that system. Now for Linux, the current Debian Linux uses EX4. And so when you're taking one system file and then you're putting it into another system, right, it might not be recognized because it is written into a different format for the file. So But all OS has a boot sector. So just like, and this is what they're referring into Windows have NVR. And this is a section of the drive where it's going to look for the code, right, to load your install operating system for the C drive. And it's going to be able to know whether you're using NTFS. Well, what if I have an older OS, just what you see today, right? So pre-Windows 7, you had Windows XP, right? And then there was ME and some lost version for Microsoft that was not successful. The transition between XP into Windows 7 and later, what you see is XP was at the cusp where they adapted NTFS back for the OS, right? So Windows NT was pre-Windows XP. It was used for like server purposes, but when they transitioned from Windows XP into the newer version, they thought that implementing a new file system was a way to go to make it more secure. So anyways, all OS have a boot section for the drive, right? So in Linux, you're going to see that there's a boot sector, right? And you would see that when they create the OS, they have to have a section where it's going to be able to determine what kind of file system am I going to load, right? And how it's going to be able to load your operating system. So in Windows, it uses the NVR. There were malware that was created to wipe out NVR. So if you have a boot-based malware, right? Sometimes it could be a Trojan or a virus, or sometimes it's a bootloader malware. It would target this specific section of the drive, right? And the files within it. So if it takes out your bootloader, simply it even deletes it or modify it, you cannot load the OS. So you do see some cases like that. Now on the later version of the Windows 7 and on, when you're looking at 10 or 11, right, you would see that it uses GPT, okay? And this also pertains to like how the system can section in the drive. GPT will have protective NVR because it is a transition, right? So this is the updated system, however, or technology, we still have to have backward compatibility. So they're saying here that it will not mistakenly read a certain partition. The way Microsoft implemented this is this technology is supposed to replace NVR, but they have to transition it from NVR. In NVR, there tends to be issues with like which drive or which section of the drive it needs to pull the OS from. We know that it's always going to be C because it cannot be A or B. Those are for floppies, right? But for the GPT, they implemented this so that way you can have a lot more drives, right? If we're looking at drives now, we have terabytes in the capacity of the drive. So your partition table for the drive becomes bigger, okay? Whereas NVR, if you know, you logically can have only 4 primary partition. So let's take that into an analogy of a house. Let's say that you build a house and traditionally you can only have 4 rooms in that house, okay? And that's NVR. Because back in the day, there were not a lot of capacity, right? You can have like maybe at the most later on 500 gigabyte, but that's much later, right? When I was in the field to start, 40 gigabyte was big, okay? So that was long ago. And then you also have operating system that require much less storage because there was not a lot of like, you know, features, buttons, things that you can click that takes up a lot of storage. So this later system ultimately handles higher capacity. It gives you more opportunity. So let's think about that same house, a modern house that you can build hundreds of rooms, okay? So that allows you to have more partition entries. That means that, so when you section a drive, what does that really logically means? It means that it takes an address on the drive, it adds it to a table, And that address is associated with the drive letter, the size of the drive, and the files that goes into that drive. Simply that. Everything is addressable, right? So that means that on the GPT, your list of partition gets longer. It's able to store, it's able to have more address in the array, and it's able to have more partitions. We talked about the house, right? We can cut up the house and make it into 100 rooms in the modern technology. But in the legacy technology, MBR, and you can still use MBR for your OS, but you have options now, right? If you have terabytes, you should be using this because that way you can have a lot of backup in data. Why is this important in digital forensic? You are going to see system invariation. You might see some system that only have maximum 4 rooms for primary, right? Or you would have a system that have many rooms, and you have to look into, right? The maximum it can have is 128 partitions. I can have 128 rooms, so you have to look into each of those rooms to pull your data, right? So understanding the difference is important. Okay, so I'm ahead of number 3, but let's go through and answer number 3. How do you change a boot setting in Windows system? And this can be important for you because let's say that you're given a system, right, to do forensic, and you have to go in and change its boot. Okay, or in the case that if you wanted to run a live boot USB CD, a live USB, the CD, nobody would use CD anymore. A live USB that contains like Paladin or a Linux virtual machine, right? You can, but you need to change your boot options, right? It defaulted to, in the Windows PC, it defaults to boot sector and also the C drive, right? The section of the drive that contains the OS. So we need to be able to access the BIOS. So that means that when you need to access the BIOS menu to be able to modify this. How do I do that? I mentioned, right? A lot of the times, depending on the manufacturer for the motherboard that's on your system, usually it's like a function key. It's an F12 or F10 or F2. Sometimes it's a setup key. You have to look into the manufacturer who sold or, the motherboard that's used, because Dell, they actually buy parts from other company and label it as Dell. So you kind of have to know the model and then research that first. So you would need to modify the boot priority settings. So in that, this is in advanced settings, right? So when you press the function key, you see your BIOS menu, right? You can only use, I think on the later UEFI, you're able to use your mouse, but in the older system, you have to use your keyboard. So at the lowest level, your keyboard is the functioning component or the IO device. So you need to change it. So you need to navigate to your advanced boot option. You need to make sure that whichever drive that you're booting from, like if I'm booting from USB, that's gonna be the highest priority, and then all the subsequent drives. So you need to know how to do that. So you would change the option for the drive and the drive that contains the artifacts for the evidence acquisition. So let's say that I need to only look at the logical image on drive E, right? Which is a backup drive on that computer. Then I would capture the image, but I need to change that system boot option so that way I can access that drive, right? So it's going to allow you to be able to pull the image for that. So because you have to remember that in IT and cybersecurity in general, your scope, you have to stick with it. So if you are asked to investigate drive E, that's what you're gonna look at. Nothing more, nothing less, right? Because sometimes in order to get there, we have to access like the C drive or other things, and we might see things, right? But you have to stick with your scope, and that's gonna come back at the end when we talk about ethics. for forensic. Okay, so know how to use BIOS is important. And then for the MBR, the master boot record, that would contain sections of your drive. So partition just mean like rooms inside the house, right? Section of your drive. The file systems that used for formatted for the OS. So XP and the earlier version of Windows, right, you would see that it would use FAT or FAT32. I think XP was when FAT32 kind of almost end, right? Going into Windows 7, they implemented, EXFAT or FAT64-bit. This is when we're able to have processor that handles 64-bit. Back in the day, you only have 16-bit and then 32-bit processor. So this is what you see. So the file systems, right? File allocation table, which is a FAT system, it basically contains a table that has all your file index. And that file index is correlated with addresses where that file is stored. So if you're using, back then, they only had hard disk drive, so your files basically scattered, right? And so it would be able to pull the files together by referring to that table. Later on with NTFS, that's a different file system, right? This is what we currently use for Windows. And then, like I said, right, know your file system for your current Linux and also your Mac OS. So your bootloader code would also be part of your boot sector, which is a small section of your drive, right? And that's going to be used to refer to your OS files to load. So bootloader and MBR type of malware still float around because Windows traditionally used that. It still uses it. Like I mentioned, right? GPT allows you to have 128 partition max. So if you have like many terabytes drive, you can section that up to 128. NBR is limited to each partition and also the maximum partition. So you can only have 4 primary, right? If you have, or in variation, right? If you have 3 primary, you can have 1 logical. So there are different ways that we can partition or section up that drive in the old NBR. So NBR can have up only to 4 partitions. So think about a house, you can only have 4 rooms, or a house that you can have 128 rooms. So usually that's a bigger size drive that's going to handle 128 partitions. Now, once you start with NBR, that's what you're going to have, right? You can't switch between NBR and GPT. It doesn't work that way. So when you set up your drive, right, when you set up your OS, when you format and install, that's how you start with that type of partition. That's what you're gonna have. If you want to start all over again, right, you have to rewipe that and then start with your different partition, or add a different drive and use that separate drive with different partitions. It doesn't let you have a mix within. I know my Microsoft well because I was certified in it, right? So I still like a lot of that because it's abundantly used. But because, understanding this is going to help you with the background, like what are you looking at and those things. Okay, so before you create a system image of the drive that cannot be removed from the system, what should you use, right? You should use, right, a USB or a CD or a DVD if it's an older computer, and make it a bootable. Okay, so how do I go through and make a bootable USB? Your OS should have that component where, there's an option and control panel under systems that you can create it. You can also pull ISO or image of your OS and be able to go through it and unpack it to create a boot drive. There are many ways to make a boot drive. There are software tools that walk you through it if you pay for that, right? But in the OS itself, you should be able to create a boot drive if it is a bootable OS. So it's always good to have a bootable USB or a disk, right, on hand when you're doing forensic. It's recommended because sometimes you're gonna need that to boot the system to pull the image. So, and again, we have to change your BIOS in order to boot it, right? Okay. So before you put in that bootable USB or the disk, right? As an investigator, you should test it. So that means that I need to plug it into another computer to see if it's bootable. Okay. And then when it boots, make sure that nothing is changed on that system. Because if you boot it and you change anything on the booting system, that means that you are changing the evidence. So you don't want your boot process to modify anything. For example, right? You guys know that a lot of the default programs, for example, if you install something that would open up on the boot, right? Start like for maybe run a backup or an antivirus or whatever it is, some application would launch on start, right? So that means that when that happens, it changes the state of the system. Okay. So what we need to think about is potentially when we boot, does that make any change to the system that we're booting? Okay. So we can simply disable some of the drive that we are not accessing, right? To be able to stop it from opening. USB like to have auto runs, right? Things like that. So sometimes if you have other drives that are attaching to it, it modifies the state of the system. Now, if that happens, right, in the process and if you don't have any other way, then you need to document it on your report, right? Because that will be an impacting factor. If it's not impacting your results, but it does modify some system information, then you need to know what that is and document it. Question? Okay. Bush. So it talks about forensic media here, where this is where you can find the information for that answer in the previous answer about CD USB, right? And then for the Linux standard operating system, you can use it to make a live USB, right? Like we talked about Paladin, which is a live, it has an option to do that. You can do this with Kali Linux. If you go to the download page, it actually gives you an option to make a live USB. Same thing with Ubuntu or other, right? And then if you want to get access to your Windows FE, this is forensic environment. You can also create it specifically for Windows. And yeah, you can look at that link to find more information about Mini WinFE, which is a package that they created for that. And then if you're using tools like FTK Imager or X-Way, it actually walks you through the process of doing it. So some software would walk you through the imaging process on how to create an image, and so that way it is a little bit more user-friendly and easier. But like I said, technical knowledge is going to allow you to avoid a lot of the mistakes. Okay, and then secure boot is going to be in the UEFI process, right? This is only going to allow you to have trusted software in the system. So they implemented this for the later OS just to make sure that only the sign or the valid type of software is allowed. So you have to be able to configure that whether you enable or disable, right? So it says that secure boot feature must be disabled in the case that you're doing forensics. So you have to do that. I put some link, and I know some of you already know about Rufus, right? You can use Rufus to make bootable USB. or disk. And then if you're running it on Mac OS, which some of you have, right, you can also download Rufus for that. And then you can also have other options. So I put down there's UNet Bootin that allows you to have, and there are other tools that you can find as well. Okay, so let's move 7 down to the next page. That's where we left off. So the 3 tools, the 3 software that you can use to create bootable USB, and you're not limited to this. There are other options, right? Paladin, Rufus, or UNet Bootin. Those are, and then in the operating system itself, your own system, in Windows, it has an option for you to also create a bootable disk. Okay, so let's talk about drives. I think I just threw most of them away. I had a bunch of hardware and I opened up some old hard drive. I had to dispose them because they had to make room in this room for that. So when you're looking at a drive, right, technically you're not supposed to open up an HDD if you plan to use it. But let's say that if the drive is bad, you can open it up. You would see that it contains these components. One is going to be a cylinder. So a cylinder would consist of many different platters. Okay. And each platter would contain many tracks. Each track has sector, and each sector is approximately 512 bytes by standard. Some disks actually have larger byte size sectors. But most disks you're gonna see, right? You saw this when you look at what was it? F disk, and we did a lab where we have to mount a USB, and we looked at the USB, and I asked you what is the sector size, right? So when you work with storage, you have to know that each sector contains 512 bytes for most of the time. Some disks, it would have 4096 bytes per sector. Very more rare, okay? And on the track, you would have many sectors, okay? But by standard, your disk would tell you how many, like on the specification, or if you look at the disk information, it will tell you how many sectors per track and how many tracks per cylinder. It also depends on the capacity of that HDD. Okay, like if you're comparing a 500 gigabyte to 100 gigabyte, right? That would also pertain, because if you do the math for this, if we calculate this out and we have a multiplier, 512 bytes to 100 gigabyte is going to be different than 512 bytes to 500 gigabyte, right? So that's going to tell you how many sectors on the track, how many tracks, and how many cylinders. So on the old hard drive, you would see that it would have a sticker, and on that sticker, it would tell you all of that information for this geometry, right? So this is physical components on the actual HDD. You said, well, we have SSD. Why do people use HDD? You still have HDD for backups, right? Old systems, sometimes you have to investigate, right? Okay. For this geometry, so hard drive information, we'll find that starting on page 4. Okay. So there are additional components. So you would have the head. So if we're looking at this picture, you would have the head. It looks kind of like your old record player, but it's not. This head never touches the platter. Okay. It never touches the cylinder and the platter within it. If you have a head crash, this touches the platter and you would hear grinding noise from it, right? So you would have an actuator, an arm that moves back and forth, and that's how it's able to go from one part of the disk to a different part of the disk. So for example, like if it's searching for files and so on, right? And it would use the laser to be able to read your disk. Like I said, right, the physical also pertains to the logical capacity of the drive. Okay, so we talked about track, we talked about sector. So when I look at the sector, right, basically that will be like a small part, like, you know how you see the purple section right here? So a sector would be like this piece or this piece, right? Or this piece. And many sectors is on the track, which is completely round. So I might have this green one, right? This entire thing is on the track. And then your tracks, many tracks is on the platter itself, right? So each of the platter, and then the platter is laid into the cylinder. Okay. Any question? I don't have a lot of these hardware components anymore, like I said, but okay. So let's talk about, let me see if we need to answer. Okay, before we answer the next one, let's look through this real quick. So there are many different type of drive. The way that you say SCSI, we call that SCSI. So the way that we use SCSI drive, it was commonly used for like mainframe systems, like the main servers, some of the bigger servers, also used for backup. You can interconnect these drives, and they call it daisy chaining. At the last one, you have to have a terminator. So that last drive is going to have a terminator signal, so that way it's not relaying. So you can group the drives together as a chain to be able to write your data. And so that was common back in the day. Then came the IDE, or the extended IDE. You see these drives with the gray flat ribbon. It uses 40 pins, and you would connect the flat ribbon from the drive to the motherboard. This was common with a lot of the hard drive back then. And then there came SATA. So when we say interface, is how we connect the drive to our motherboard, right? So currently, if you are buying a HDD, right, you are still using SATA 3, I believe. I don't know if they upgraded to 4. But serial advanced technology attachment, if you compare SATA to IDE or extended IDE, definitely faster, right? Your transfer rate is much faster compared to the old connection. So as we upgraded the drive itself, the architecture for the drive, we also upgraded how it's interfaced. So you are able to have faster read and write. So your input and your IO rate is higher. And then for the SCSI drive, they also upgraded to serial attached SCSI using SAS. This is the current standard for commercial environments if they're using SCSI drive. Now, most of you probably own solid states, and I love that it is much faster than hard drive. It gives you less error or mechanical issues. It doesn't have any kind of mechanical component like the actuator or the head. So your storage doesn't have moving parts, so you don't have that problem. They basically are memory chips. So it is with memory addresses and how it's able to quickly access it. You can have it in a smaller actual adapter, right? So your drive can come in a compact or even larger, and your interface is slightly different. The things that you need to know about SSD is, one, you need to have wear level where it writes across different chips. And so that if it uses the chips in the same rate, you would also have the trim option where this wipe the unallocated space of the device. And so that would be it, right? And then it does garbage collection automatically. So that way it looks at different areas of the drive. So if certain data has been deleted, it's supposed to clean that up, right? That's ideal, right? But doesn't always happen with all technology. So firmware can only delete data in a certain block. So what it does is it's going to set a block where all the deleted data goes. We call this a slack space, right? And then after it goes into this block, then it can only go to that section to delete the data. Now in forensic, this is the area that's important for us, right? Because if it hasn't been trimmed, this is the block, the slack space that we need to find. So on the SSD, this is where you need to find, okay? So now firmware automatically does the garbage collection. So sometimes you're gonna see in the later lab that sometime when you cart the files, you're gonna see that it might only find bits of that data. So for example, if a picture was taken and if it was deleted, you might be able to find its icon still or its name. Like the file header might still be on the block where it hasn't been written over, because you know that it's dynamically right. So even when it puts it into that block, right, it's in different addresses. So even when it does a garbage collection, it might delete a big portion of that data, but some parts of your file header still remains. So the slack space is where you can find some information in some area of the HDD as well. Okay. Okay, so I think I touched a little bit on MBR before. We talked about how MBR can have only 4 partitions. So let's say that when I create the partition for my Windows OS, right? If I select MBR, right, the first partition is automatically going to be a primary partition, right? And subsequently, I can have 4 primary partitions, or in variation, I can have 3 primary and a logical. So you must have a primary partition to boot your OS. So when you create that section for the C drive on the HDD, right, or your SDD, that section of the drive, in order to install OS, it must be a primary, right? And when you boot the OS, if it is a bootable OS section, it is going to be an active partition. So that means that this, right, if you have a loadable OS, it becomes an active partition, but it is a primary partition. Okay. It's kind of like saying all house, right? If you use the 4-room model, right? All house must have a living room, right? That's where everybody resides, right? And in order to have the OS, you have to have a primary, you have to have that living room. And in order to live in that house, right? So you have to have an active partition, but in order to have an active partition, you have to make it a primary partition. So that main section of the drive is always going to be like that. So when you do the lab today, you're going to see it looks like this, right? And the important information on the right-hand side here is important. So your FTK, your forensic toolkit, we're going to use ProDiscover today, right? Which is free software for us. You're going to see that when it looks at that part of the drive, right, it's going to give you something like this, okay? Where it can pull from the partition table, and it might indicate, so sometimes we might look at the hex value, which indicates like the location of the file itself, right? Remember that these are all addresses. And then sometimes if we hover our mouse over it, we might see some information, for example, like this one. It tells you error loading operating system missing, right? Like I said, if you came across things like bootloader virus or malware, you tend to see that little message pop up when it's trying to pull your your boot sector and your boot loader, which is your code to load your OS. And if your virus or something corrupted your bootloader, it's gonna show you that error. So you're gonna see something like this. Okay. So it tells you here that the first 440 bytes are highlighted. This is your boot code, right? So your boot code is depicted in that picture. And then you see that with the pink? And then the next 4 bytes on the disk is gonna be your OS signature. That's how it's can tell you. It can tell based on that what operating system that you're about to load. The next 64 bytes is gonna be your partition table. So that's how it's gonna determine how many section of the drive and which section has the OS information, right? And then the 16-byte entry refer to specific partition like the C drive or the E drive, etc. So if my C drive has the OS, it is an active partition, right? So it's going to look at how many primary partition from the partition table, and it's going to look for the signature, which is going to tell you like the OS, which OS is going to be loaded. So today, when you look at Pro Discover, right, try to look at the boot sector and see or the OS information.
Is that listing provided symbolic of the color code on top? Like, is the pink the first 444,
Yeah.
and then the dark blue is the can't see the color.
Yeah. So the next 4 bytes
is the white.
Yeah.
And
then the 64 is the subsequent. Okay, so you're gonna see hex values like this. That just represents location, right, on that disk where everything would be. And so it tells you in the next screenshot, right? So you would see hex value, and then the first byte would be designated to the partition of the active partition. So if you see the 80, that would identify the bootable partition. And the hex 00 is non-active, right? So the difference, how can it tell if it's a bootable drive, right? A bootable section of the drive or a non-bootable? It's because of the hex value. So if you see the hex 80, which is right here on the second line, row, the first row, the second line, right? That's how it can find that's an active drive, right? Compared to 00, which is subsequent, those are non-active partitions. And so it gives you the breakdown, right? Where it's going to look at the sector, your CHS, which is your cylinder head and sector. So if you look at that screenshot, you can pull it out from the Word document, make it bigger, right? It tells you which hexadecimal it represents what. So the 5th byte represents the file system, and that is represented with the DE. And then so that would tell us about the utility, and then the hex value 07, that would tell you the type of formatted file system. So that's how it's able to distinguish between NTFS or FAT, right? And then if you look at the value 05 or FH, this is going to be extended partition. So in MBR, you can have only 4. Let's say that if I wanted to make more, right? I can't. So I can only extend on an existing primary or an existing partition. So if you're trying to cut more room in that house, it would only take a room and expand it. It doesn't allow you to make additional partitions. So they are known as extended partitions. Okay.
Is there a limit to how many you can?
Yeah, MBR you can only have 4. But if you're trying to add more, it's gonna take one of the four, and it's usually the last one, and it's gonna try to extend it. Unless you specify it by the drive letter, right? So if you want, so when it looks for it, it's gonna compare the hex value, right? So if you see the 0, 5 or the FH, that would indicate that it is an extended partition. It just added on to an existing partition. And potentially that could have data, right? And then it talks about the 3 bytes value, which tells you the ending sector. Those are just pieces on the track that would contain some information, right? So the next 4 bytes is the starting sector of the partition, and the last 4 bytes shows the size of the partition. So that's how the system can distinguish, right? Which sector on the partition and the size of that partition. So if I cut my drive into 200 gigabyte, this is gonna be where it's gonna find that. Okay, so I highly recommend, right, going through this bullet list and then look through some of the images I tried to pull for you. Okay. And then the extended partition would look like this. So you have 3 primary here, and the last one is the extended. So let's think of it like this is an MBR. So, and it uses VBR to look at the first extended logical partition. So some textbook, they'll call this logical, like Microsoft, they'll call it logical drive. But it's extended logical partition. So it will look at this last, so it uses the extended boot record to look at the extended partition. And then the VBR, it talks about the volume boot record, right? And that would look at your boot operating system for the volume. You're like, so what's the difference between a volume and a partition, right? So a partition really pertains to the physical cut on the drive, the section, okay? And then the volume really represents the drive itself and also the capacity in a logical level. I don't know if that can help you clarify, because sometimes, right, in some cases you would see them as the same equivalent, but they are technically different. Okay, so let's answer the next few questions. So what is an active partition? We talked about an active partition is where the primary partition is able to boot the OS. So on your system right now, if you look at it, right? I will see if I can pull that up. So give me a second. You can find all of this in this management console. Let me see if I have Windows Pro, I would be able to. So computer management console. And so in computer management console, if you have access to that, you would see, so this is what you would see right here, right? This is your partition table and all of that, right? So in your disk management console, you would see, in my case, I go to computer management console and I can go to disk management. This is a feature or a tool that you can use, right? So now if you hover over a certain drive, right, or a partition, it will tell you the partition type, okay? And then if you know, so, and then on the top, it would also tell you, right, how many partitions. So for example, I have this is for my UEFI partition right here, right? And then I have a recover partition, but my OS, my active is actually here, right? And how I can use BitLocker and encryption is because it is formatted in NTFS. That's an additional feature. So if you use FAT, you are not allowed that, right? And so now when you look at the partition table like this, if you have extended partition, so this is with GPT now, right? You would see that you would have, if it's MBR, it would say it's MBR, and then it would have 4, like what you've seen in the notes. And then the extended partition will be color coded different. So when you see it in blue, right? If that's considered primary, and then the black is unallocated. I'm a type of person that max out my drive and I want more, right? Because I have a lot of stuff to store. So you don't see, but if you see a drive that has unallocated, it would be like in black. And that's basically space that's not given, that's not cut for anything, that's not like a space in a house that's not designated to a room. It's just empty space to be used later, right? Unallocated is different than free space, okay? Free space is things that, let's say that you have a house and you have this empty space that you are not using it for anything. You haven't decorated, you don't put carpet, it's just there, right? But free space is you carpeted, but you haven't cut it for anything else, right? So free space could also be pre-formatted, but it's also used, it can be used for storage purposes down the line. So unallocated simply is just not designated for any room yet or any partition. I think Microsoft tried to do away with free space information. Okay. So we talked about the purpose of volume boot record. This is to use to boot operating system located at sector 0, right? Because boot sector is the first sector on the drive always for all OSs. So when you install Linux, right, if you just click next, it does it for you automatically. Same thing with Windows, but you can manually do it when you click advanced option on Windows, and then you set up your C drive so you can cut up your disk in however many gigabytes or terabyte that you want, right? It also set up the boot sector with the process. Okay, so your volume boot record is going to refer to boot sector 0, or sector 0, which is, you know, if you see that little piece, right, on the actual platter, right, that's the first piece. What is the purpose of extended boot record? This is for to find or to point to the first extended logical partition. That's if you have one. Now it's always going to exist in the case that you create one, right? But so if you create one, it's going to use the EBR to find your extended logical partition. And MBR is different than GPT in that globally unique identifier is used. You can have up to 128 rooms or 128 partitions. It uses 128-bit hexadecimal to identify different aspects of the system. So having that, if you take, right, 2 to the power of 128, you exponentially have more addresses. This is why you're able to fit more drives on the logical drive. Okay. So it's all about manipulating that, and that's how you're able to get more capacity and more drives. Question? Okay, so let's talk about host protected area, your HPA, and device configuration overlays, your DCL. These were things that were implemented when they created the hard drive, right? And these are for hidden areas on the drive. HPA is used for storing information like Western Digital, the manufacturer company, right? Diagnostic tool. I don't know if you actually ever use drive diagnostic tool, right? Maybe you might have some drive comes with specific diagnostic tool to look at like error rates because it's input output. So it's going to look at to see the performance. On a lot of the industrial drives, you're gonna see these options more apparent, like iOmega or some of the manufacturers that produce the drive for backups and things. So what you see is, so HPA is basically an area on the drive where it stores the tools and the manufacturer information, warranty information, etc. Often that you cannot use it. For example, you bought a drive from Western Digital and you put it on your computer and it's not working and you have a 2-year warranty or 1-year warranty. You send it back to the manufacturer, they are gonna look at the diagnostic tool and they're gonna see like, why is that drive not working, right? As part of your warranty. Okay. VCO, this is an overlay that allows them to use standard parts to build different products. And this is what you see in variations of all different drives that are in the market, different model. And so you might have an SSD that is plugged into different bus. So if you use BME or if you use like maybe for PCI Express, etc. Right? There are different ways that you can connect your drive. So they're able to overlay this one time. It is basically a generic way for them to adapt different components to produce different drive for that part, right? Because it's basically a memory chip. And so you can have different ways to adapt that drive. And on the hard drive, you see there's a board on the bottom, right? Where all of this also is referred to. Okay, so let's talk about file system. We talked about file allocation table. Your USB is always going to be FAT, right? Currently, USB is at FAT32 or exFAT. That means that all operating system, Mac OS, Windows, Linux, and same thing with micro SD, can use file allocation table. NTFS, as you saw, is specifically for Windows systems, and NTFS allows us to use encryption, right? It enhanced security. That's why they implemented it. But the ultimately file system in an operating system is a way that the system can track the file, right? And how much space in that partition that is used or not used, right? So it's a way that the OS itself is able to locate the files and the space that's used for that files. So if you, let's say that in my case, I have like 25 gig left on my drive. So I always have to like manage that, right? Because in order to have more, I have to add another drive. And so that means that there's boundary to my capacity, right? So if I try to store something, let's say I try to transfer my backup storage, that's more than 25 gig, right? My OS would notify me. It says that I cannot, let's say I try to transfer a 32 gig set of folder to the drive. It's going to reach the boundary. It's going to say it cannot transfer because my maximum capacity has been reached, right? It's kind of like you have a room and you try to stuff more things into that room, more than it can hold, right? It's going to burst by the seam, but the OS is going to say, no, it's not going to allow it because it's reaching the limit, right? So you cannot put more than what's there. So that's what file system really intended for, to help you manage your file. Okay, let's do the breakdown. Let's take this down a little bit. Okay, so FAT stands for file allocation table. This has always existed since earlier Windows versions 98, carried all the way to XP, updated to 32-bit. If you're using USB, or in some cases we can still format 32-bit, it just has less security. So the way that was created was a little bit different than what you see in the other the other file system for the OS. So in file allocation table, when the user adds the file to the system, it will update the table. And because the file would be located in different areas of your drive, different clusters. So that means what? Your file one, or the current file that you're using now, right, to do your assignments, it would be in different areas of the drive. And it would have multiple addresses. So this table is going to say, let's say file one is going to have these addresses, right? And as you save the file, right, or change the file, let's say that my file grew exponentially in size, right? It will take more room, so that means that it would add more addresses to it, okay? Or for example, you have a design and you modify, right? And you add more to it, like 3D animation, because that exponentially grow in size. You are gonna see that it would add more addresses to it because your files just get larger and larger. Now, the clusters, as you know, is not sequential. So this is why files can be in different places, right? In the newer ways, we can optimize it much better. This traditionally FAT was made for hard disk drive. So this is why once in a while you have to go through and, reorganize your file together so that way you can search for it quickly. So it would spread in different location, and this is called fragmentation, right? So when you defragment in the older version of the Windows, basically you're just trying to reorganize it to one area. So that was the downfall, I think, for file allocation table, and also the drive technology that we had. It was slower, it was more difficult to search or access file quickly. You notice that now if you use SSD when you're searching for your files, even though in my case I have thousands of files, right? Sometimes I'm searching by index for character. It's quicker, definitely faster. Okay, so I put down some RFC information for your GPT information. And then also I recommend that you look through the example that's given to you, and it talks about the hex value, right? What is indicated for the UEFI signature. So it looks slightly different than the MBR where things are located. And then a table to indicate the offset or the table format. Your HPA and DCO information is on page 13, and also file system. So we just talked about file allocation table, right? And when you look at it with the volume, it will be like this. We can pull this out a little. So it tells you, so I put down the bullet list of what the hex indicates. So 00, that will be the jump instruction after booting. So it needs to go to the next section of the disk in order to, to get to the OS information. And so each of these value indicates specific thing like number of sectors. And then for the file allocation table, it's going to use hex 16, right, for FAT32. So if you look at 1C, that will be the hidden sectors, right? This is going to be before the start of FAT32. So look on that image and see if you can find that hex value. Just keep in mind that this part, right, takes time, and software wise, a lot of the time software is going to help you with like be able to find things a little quicker. But if you have to dig deeper, you have to look into the hex value on what the software has given you. So sometime on the software, if you just click on it or hover your mouse over it, it will give you some kind of output information. But knowing like specifically what each area means is also good. Okay, just like what we talked about before, hex 00 just indicated not used. If it is allocated, that means that it's cut for specific partition or format, right? You're gonna see that it would be in a certain cluster for the file, and for the cluster 7, it will indicate hex 7. If you have a back cluster, you're gonna see the F's in front of it. And if you learn assembly, right, you already know that this is an assigned value. It's a negative value. Okay. So back sector is usually indicated with the F, which is a signed value for the hex. And then for the allocated, if it's used for a file, sometimes it's also indicated with the F, right? F is the last value in the hex systems, right? 0 through 9, A through F. F is the last value. So when you see it fills with the F right here, right, that means that the file actually occupied that space. Okay, so as we indicate, a file can come from multiple sectors, right? Or even different cluster. Okay, so let's talk about file names. You know that you can have 255 characters for a file name. This traditionally has always been around. Depending on the encoding systems, a lot of the times your special characters are not allowed. Why? Because it's the encoding system value, right? The way the software is created. So for example, in Microsoft Word, you're trying to save a file. Well, you can use a hyphen, which is a dash, but you cannot use other symbols like a question mark, right? Because it's an encoding value, because each of these symbols converted to a value, right? And they only give you a scope. That means that you can only reach a maximum numerical value, right, for naming your files. So the requirements for long file name, up to 255 characters. For the short file name, we can have only up to 8 characters. Okay. Now, if you have a file that has less than 8 characters, it's gonna pad it with a hex 20. So when you carve it, you're gonna see that when you see that hex 20 indicates that it is like a file name that's shorter than 8 characters. So for example, if I put IOU, right, as a file name, the rest of the characters is gonna be padded with this hex value to indicate that it is a short file, a super short file. Now, you are always gonna have the extension, the file extension, which is, standardized with dot 3 characters, like dot. Now you see the new application like dot X, right? But standard wise, you see that most of the time your file extension is with 3 characters. If it is less than that, right? Like let's say if it is dot DT, right? That would be padded also with a hex 20. So if you remember, right, hex 20 is then being used to pad in file naming anything that is too short. And then if you're using space following the characters, that is not permitted, but some characters are permitted, not all characters are permitted. And so, and then directory, sometimes you would see that it would, I think now we don't really require this, but when they say directory, you know what that means? Those are folder, okay? So directory entry will always be stored with an uppercase. This is a common standard practice, but you don't always see that. So like the first letter. So let's say that if I name finance as a folder, directory, in standard practice, you would see the F, the first letter is then capitalized, but now it's not always standardized across all OSs and all systems. Okay, when you have time this weekend, read through the data section of your FAT. Look through the image that I provide, right? It talks about how you can follow the hex 00. We see some of that today. And then go to the next level. So you would see like the character of the file name. And this is how when your software, when it carve out the file, it will tell you what file it found. And so based on the location, right? So when we say it's padded, it would go to like this part of the disk where it looks for the file name and how it's able to pull out the file name, right? If it's padded with hex 20, that means that it's short, it's too short, right? And then, the file header information, like when it was created, when it was modified, right? It looks at hex 12, which is that part, that address location to look at like when it was last opened. So access is different than modify in forensic, okay? Modify is when you change the actual content or the state of the file, where access is you can simply open it and look at it. So 2 different things. So this is when it's going to look at different area of the disk to be able to determine that. And here also date of last write to the file. So this is for modify right here at hex 18. So if you look at the image, right? A lot of the forensic people, this is the favorite things, right? It is a little harder because it's tedious, like you have to go to each area if your software is not giving you what you want. So experience and expertise wise, you kind of have to dig deeper. But with practice, you are going to get better, right? So we're going to use the software today so you can see the emulation of your disk and its addresses. Okay. All right. So for a long file name, how does the system allocate space for very long name, right? I said it will go up to 255 characters. So it's simply create a nickname, which is an alias for the first three characters after the file extension dot will become the extension. So it basically shorten it using an alias. I used to have a supervisor that likes really long file name. It used to drive me nuts, right? It's because it's hard. But some people, like if you are in software development and things like that, you have to do version tracking, and using many characters to track your version is important, so that way you can see variation in your development work. But in the case that you have really, really long file names, right, it's simply shorten it using an alias. This is how it's able to save the space, because remember that even the file name takes up the space on your system, right? So the first 6 character will be converted to an uppercase, and that will be used as an alias. And then in most system, it's going to use a till, like the little wiggly sign is called a till, right? And it's going to add a till, and then it's going to follow it by number, right? So it will be like 1 or 2 or a value. So it will start with a 1, and then it would then increase incrementally as you would add additional line to the alias. So when you carve out a file, and if it has a long file name, this is how it's represented, okay? This is why we're going over this. So you would see how it's formatted. So if you see a till or an alias, that just indicates the original file has a very lengthy name. And how it's shortened is the first 6 characters is then converted to the uppercase. So you still have part of the file name presented to you, right? But it would shorten it to kind of show you. So it would look like this. So here's my example. My trip from 2020 from Hawaii.jpg. And you see people save things like this, right? When they take a picture, right? So it would take the first 6 character and convert it to my trip. Add the till, the rest of this is then condensed to 1, right? And if I have more, right, like another line, then it will be till 2. But anyway, it will be something like this. And it will be JPG because this is the file extension. Remember that it's long file name, and they have to make it different than the short file name. So it automatically become uppercase. Okay. So most of the software, when you carve it, sometime it will give you something like this. So we have to kind of learn how to work with the longer file name if we see it. Question? Okay, almost done. Okay, so I just went over some binary stuff with my 40A class. But at the binary level, right, this is indicated as 0 and 1s, of course. So in the case, if you're looking at a binary value that represents a long name, right, it would be something like this. Because a lot of times everything is represented in a byte. So that byte, this nibble, right, all of the ones converted, and you can put this into a decimal value or a hex value. So technically we should convert it to a hex value, right? So if all the 4 bits is on, if you plug that into your programming calculator, you can actually find and going back to the earlier note, you should know which character that is, right? So it would look something like this for the archive file. So you guys know the difference between archive and non-archive file? So historically, when you archive a file, and we often see this now more with just only backup, it's simply add an attribute to the actual file header. that means that the A attribute is indicated. This is when sometime when you do a backup of a file. Once you back up that file can now be archived, right? Because we don't really need to access it anymore. We don't officially back up a lot of the files that we back up the files that we're using for the case that if we need to refer to it to reuse. But a lot of the backup files that may be for storage purposes, so it adds this attribute. And so in that sense, anytime that it adds the archive attribute, you would see that at the binary level, this bit is gonna be activated. So at the lower level, it's simply modified that particular bit to indicate the attribute has changed. And you do see this in like command line or in some software tool that you would see. So that's how sometimes that we can distinguish between data that has been backed up to data that has not been backed up, right? Is the property for the archive bit, the archive bit. And then long file name information, there's some also illustration, right? If you look at the brown section, it also indicate the till, right? Long file dot text. Bless you. Okay, so some of the things we're gonna do today is we are gonna pull some stuff that's been deleted, right, from the image that we're working with. And so when you're recovering deleted files, we would see that. So so let's talk about the process of deleting. When someone put the file into the trash bin or the recycle bin in Windows, right? That space of the file where it originally stored goes into what we know as a slack space. It is not an unallocated space until that recycle bin is empty, right? But even when it's empty, it's not fully an unallocated space. It's still a slack space because all your system reuse that space. So basically it gives that space back to the OS and it's gonna say that space is now become available for the next file, right? So that becomes a slack space. Now, sometimes you are gonna see clever people putting things into the slack space, okay? A lot of people are gonna try to delete to cover their tracks. So you have to dig file out from the slack space in general. Okay, so that's what we're going to talk about. So it tells you here that you need to really determine the beginning sector, right, on where it starts. And we would then go through and look at that whole cluster where that file used to be, okay, to see if there's things that still exist. Now, if you change the value, the hex value from 00, which is because the file was deleted, to all Fs or F8 because of the cluster size, right? Sometime all the way to 0F, you would be able to look at the entry point or the information, the entry of the actual file. Okay, so when you recover the deleted files for the evidence first, this is the first step. I try to summarize the whole section for you. Find the first cluster of that file. That's gonna also, remember, when you look at file allocation table, right, where is the size of the file? That's gonna also lead you to the size of the file, which is your next hex. And then the size of the cluster in the volume, because remember that it can spread across many different areas of the cluster. And to find the file size, you're gonna look at the 4 bytes, the last 4 bytes. So on the software, you just hover your mouse or click on that hex value on the last 4 bytes. So and the reason why it's 4 bytes, right, 32 bits, And then determine the sector size from the file size. So once you have the file size on the last 4 bytes, right, then you're going to be able to determine the cluster size. Now, the cluster size is going to be based on how large is that file, right? So we talked about a sector is 512, right, bytes. And so that you would need to kind of do a little bit of basic math. And then that's gonna lead you to the sector information. Or, I'm sorry, obtain your sector information in the boot record. So the boot record actually has a lot of the details for your file information. Okay, last one. Let's move 19 down. And then we'll take a break and we'll do a lap. Okay, so the slack space, what does it contain? It contained the data from the previous file, like if it was deleted, right? Because normally people right click or put it in the trash bin, so it contains the information about that file. Until it is overwritten, the data will remain for you to examine. So if that space on the SSD or the micro SD or the USB or the drive is not written over by new files, you can still pull remnants or the entire file. So this is why people pay a lot of money for forensic, is because it requires a lot of technical knowledge in order to pull or recover data if it was deleted. And there are software that actually pulls everything that, you know, especially on iPhone or Android, they can pull all the text, all the email, all the things that's been deleted that was stored on that phone, that is, right? Now, a lot of the time we store everything on cloud, which is, you know, so only if you load it to the phone and you read it in the phone, let's say like a picture, you save, you delete the picture. And in some cases also puts it in temporary storage. But a lot of the things you can also pull from RAM. So today we're gonna work with the permanent storage, and then in the future we'll work with the temporary storage. Okay, slack space information is here, right? And then you can read more about NTFS. So new technology file system. So it is slightly different than your file allocation table. So when you look at the software, right, on the file system, the software is going to tell you at the top like that. You see where my cursor is? On the other one, you see it as FAT. On this one, you see it as NTFS. And that's going to kind of help you on how to navigate through and look at like the location of the file, because they are slightly different. So if you look at the hex value, right, the hidden sector, the number of heads. So these are the hex value column right here, right? And then, so if your signature is at this value, and like your file allocation table, you're gonna see it's gonna be with hex 80. Okay, so take a look at the image, read through this section, compare this to FAT. How is that different? Okay, any question? We are gonna have to file card for our final project, right? But we're gonna practice from this week on out. We're gonna do different type of OS, different systems. So you're gonna card file starting today. Okay, I'm gonna stop and take attendance, and then we'll take a break.